Sure.
So, okay, we're just checking that the live stream works so that we make sure that things actually get recorded and live streamed. Let's see. Does it? Yes. Okay. Can you say
Okay.
something?
Hello. Can you hear me?
It has a little bit of. Yeah, it works. Okay, fair enough. So you can just start. Great. Welcome, Hugo.
Okay. Okay. Uh, so yeah, happy to be here. It's a shame I could not make arrangements to travel there. It seems like it's really fun, and but yeah, hopefully for the future I'll be in one of the Wizard Amigo events. So yeah, let me share my. Okay, I think it's ready. So just to confirm that you are hearing me and you are looking at my presentation. So if everything is fine, let me see if I can see the chat here because I'm not hearing you now.
Hear you and we see it all. There's a chat on the side somehow. Uh,
Let me open the chat and a little
but yeah, it
go
seems
with.
to all. I think if you go, on top in the top corner.
All right,
Yeah,
great.
it works.
Okay,
So we will
okay,
mute
okay,
ourselves while you present, and then later we can do the questions
okay,
after.
great. So yeah, so the idea of this talk um, is to have a like a general overview of WebAssembly, ROS, and how things like communicate between each other. So the challenge with this topic is that you find some really advanced content out there. So it can be discouraging for some developers that are curious about that, but I know because I experienced it myself, like it's a little bit overwhelming sometimes. But after doing some experimentation and like exercise and reading the documentation, it's really not something hard. I mean, you can do some cool stuff without being a Rust expert, even. So yeah, like I think like the one of the key points is that there's some benefits to learning about WebAssembly, and I think that in the future we will be using a lot more of these tools. And one one interesting thing about this is that more developers from other areas and other backgrounds will also be able to share in I mean libraries and code, and so there will be a richer ecosystem in the web platform. And I think that will be in part caused by the WebAssembly uh, progress that we have been seeing in the recent years. So the first idea that I would like to share is like where should we use WebAssembly, or like, and there are like two schools of thought, but like you can find projects that are really cited on the like more Rust than JavaScript, or maybe people are not really familiar, or they don't like the JavaScript tooling, so they prefer to write everything in a language like Rust and use the all the tools that the compiler provides. Like the Rust compiler has a good reputation of uh, like helping you like write code that works after some struggles, but it's a nice tool. And also like the current state in web applications is to write everything in JavaScript. So another key point here is to find that sweet spot, and this is really subjective. So you can have uh, projects that use like a different rate of Rust versus JavaScript and the opposite. So, and you can also start like taking a JavaScript project and gradually like move some specific small functions to Rust. So that's also another possibility. So yeah, it's really like there's no one formula for making things work. So just to like just so you can have that clear. And yeah, the why is like there's a lot of reasons, but like three of them are like yeah, you can write your domain logic in Rust. So one of the I think a nice approach is making use of all the validation that the Rust language and the compiler gives you, so you can have like a really large code base and make sure that things work really well. Because it's compiled, you can catch the errors at compile time. So that's like a one approach. The other one is maybe you are not uh, really interested in Rust at this point, but there are some libraries that you can use for your own needs. So maybe it's some image manipulation library or something with cryptography, security, or just like one algorithm that has a nice API in Rust, and you can reuse that. So it opens like more possibilities for web developers too, in terms of like available libraries. And the last one, because this I think this is really fun. There's still a lot of progress, and some things are more polished than others. So right now I think it's a good time to just experiment and see how things evolve. Uh, I gotta. Okay. And yeah, like I want to show you a couple of examples, just so you have an idea of how like how it does look like to work with Rust and WebAssembly from a JavaScript application. You can use WebAssembly in Node.js, like in native applications, but here my focus will be like the browser. So this is like a basic example of just capturing one input and processing it. In this case, it's just like computing the factorial number of an, one value. And this is the code that you as a client of the WebAssembly module will use. So the key point, the important point here is that uh, the syntax is really similar. There's nothing different to what you already
Awesome.
are used to in terms of using functions, modules.
You can
So
also adjust camera, that
there's
might be
just
useful.
one object called Wasm bindgen, and that's like a global variable that is created by the wrapper scripts that are generated with the package, and I'll tell you more about that. But inside that, there's all the functions and structs and other utilities that you want the Rust code to expose to the JavaScript world. So here, usually you will find that the binary file has to be loaded, and then you just like initialize the module, so you can use all the functions. So here we have the function factorial that is defined in our WebAssembly module, and yeah, it receives a number and it returns a number, and after that it just displays it in a label, in a normal HTML element. So yeah, the point here is that there's like 3 4 lines of initialization, and after that you just use the methods like as if they were created in JavaScript. So I will tell you about what happens in the background, like for this to be possible. But first, I want to show you another example of how to use the same code but inside a web worker. So in a web worker, you just have to take into account like the limitations of web workers. And right now, the support for modules is limited. Like Firefox doesn't have support yet. So with that in mind, you have to make a couple of changes when you are going to generate the WebAssembly package, just so the JavaScript wrappers do not assume that modules are supported, and they will be generated as normal JavaScript files that you can load with import scripts. But after that is like basically the same code. You just use a function that is defined inside the Wasm bindgen object that was globally defined. And yeah, so there's no much of a difference there. And let's see a more interesting example, because here things here you can see like how to use more complex operations that may be defined in an external library. So in Rust, there's some crate, as they are, as libraries are called in Rust world, that is called Photon, and Photon has support for transforming images, like adding filters, effects, a lot of stuff that is kind of expensive in terms of computing resources. And the authors of Photon included support for WebAssembly, so that's important. Like not every library in Rust is compatible with WebAssembly, but a lot of them are. So the idea here is that you just from JavaScript you load the image pixel data, and using normal JavaScript constructs, and the function add effect is the one that is defined in Rust. So I'm going to show you later how it's defined. And it receives the byte array with all the data that we loaded from the web page with a simple input file element. You pass also the width, the height, and it will return the transformed pixel data. And after that, using the image data, we construct an image of, in JS world, and something that we can display in a canvas or in an image. So how does this work in real life? I'm going to show you the example. So I'm going this, yeah, just load one file, press load, and it will show the normal image and the blurred image. This has a blurred filter applied to it. And as you see, like this is kind of cool, because you can use that to create an npm package with some API that you would like to offer, kind of grabbing the Rust library. So, and as you see, like there's some byte manipulation stuff, but this is mostly related to how the image data works. It requires an array that is clamped, and clamped in the here means that it will just have values from 0 to 255, and it will just allow those values. But yeah, like that's from the client, from JS World, how it will look like. And in Rust, it will be this is the Rust code. Like we are not very interested right now in the specifics, like, but basically it will use the photon image element and the Gaussian blur that's defined by the library, and it will pass the reference to the pixel data, and after that we just get the raw pixel data, and that's sent back again to JavaScript. So like again, there's no time, or like it will be really difficult to get into the details of the Rust code here, but as you see, it's not a lot of lines for this. So let's take a look at another example. So I want to show you how to define structures in Rust that you kind of classes that you use in JavaScript, because that's another common scenario. So I'm going to open here. I have a wizard file in Rust that defines a couple of structs. One of them is wizard, that just have a name and spells. Each spell has a name and some damage. And a wizard can cast a spell. Basically, it will just create a random spell, add it to an array, and this is just Rust. So this will live in WebAssembly space. And there's a method to get the spells. So here, like creating a spell, we'll just randomly choose from one of these strings. So that's the Rust code, but let's see how it looks like from JavaScript. For that, okay. Yeah, so the important part here is just this this part where we create a new wizard. So magically, like have access to the class or struct in Rust terms that was created. So what happens here is that there's a bridge that will allow us to have a compatible API with some limitations, but you can, as you see, you can use the methods that we defined. In this case, cast a spell, and we want to show the spells every time the user clicks the button. So I'm going to show you how it does. Just by clicking this button, it starts like showing all the spells randomly selected. So yeah, it's a really simple example. But yeah, the idea is that here we can use a structure defined in Rust world with the logic, and it can be a very complex logic that someone else created for us, or we created ourselves. Yeah, that's cool to reuse that as if it were a JavaScript object. So there's like some rules related regarding restrictions between what can you send to Rust world, what can you receive. Those are the things that you will find well documented. But I want to show you tell you about some of the concepts that you will find, just so you have an idea, a global idea of what's like involved in all of this. So, yeah, the idea is that there's a package, like when you are working in Rust or other language, you will have some tool that will compile the code to a binary file that is compatible with the WebAssembly instructions, right? That's binary instructions. So you will get a binary, and also to make things easier for the developers that consume this, the tool will generate some JavaScript wrappers. And if you want, you can have also some TypeScript definitions. So basically, you will see a list of generated files that will look like this. So some of them are the TypeScript definitions. If we go, let's open one of them just to see what kind of code does it have. So let's see this one first. So I open one of the generated files, and yeah, there's a lot of code here that we are not interested in right now. What this does is make it easy to convert from things like strings in JavaScript world to strings in Rust. Uh, but let's find, for example, our wizard class. So here, the the tool that generated our package generated some wrapper around the wizard class, and this basically deals with memory allocations and constructors, and like it creates a wrapper with the API that we defined, but internally it will call the Rust method, passing a pointer to it, and this is like internal details that we are not very interested in, like in the day-to-day. But just in case, you can take a look at what's happening here if you are interested in like knowing how memory is moved from one place to another. You have that file. So yeah, that's the Rust package. So one thing that like another concept and tool that you will see mentioned is Wasm pack. And the goal for this tool is to generate an npm compatible package with all of these files. So I created a repository that I will be sharing with you that does not use any bundler like Webpack or any or Rollup, just so you can see how it's done with vanilla JavaScript. But you can instruct Wasm-Pack to generate code that is compatible with bundlers if you are already using one. And, and this is like Wasm Bindgen is the bridge that is actually doing the transformation and trying to map between the concepts in JavaScript and the concepts in Rust. So this is kind of the heart of everything here. It's what makes it possible to communicate between the two worlds. And this will provide us with a decorator that is called Wasm Bindgen that you use in your Rust code. So you just decorate your functions. And I will show you right now one of them. So let's open. If you see, like in this file, every function it's decorated with Wasm Bindgen, and this will instruct the tool to include it as part of the exported package. So also there are some rules around how to export a constructor. So for example, for our wizard struct, we specify that we want to export this as a constructor, so it will properly translate that to the JavaScript conventions. Yeah, so let's. So this is like a lot of stuff, and it's really a high-level overview. But if you have some Rust knowledge and you don't want to use JavaScript a lot, like you can also use these two modules in Rust world that are called WebSys and JSCs, and they provide kind of a wrapper for most of the web platform elements. So you will have all the elements that you can access from JavaScript, like for WebGL, for audio, for Canvas, DOM manipulation. So I've seen some libraries where authors stay mostly in Rust world, and they just make use of all these wrappers. So like I don't see like a benefit of doing it like in that way, but it's another alternative. So yes, I think this is like what I have. I know that it's difficult to include like the specifics, but hopefully there was something that will catch your attention, and maybe you will be inspired to keep exploring this and maybe include it in your own projects. So one interesting aspect of this is that you can create your npm modules and libraries, and the final user doesn't even have to know that there's some WebAssembly code running, because you can kind of just provide the user with the API that looks like normal JavaScript, but for some specific parts that you need more maybe performance, or just because your logic is defined and as your preference in Rust, well, you can expose that, and it opens a lot of new uh, possibilities in for the web platform, and for web developers. So yeah, I think this is this is it. So I'm not sure if we can. Yeah, if you have any questions, you can contact me. I'll be happy to chat. So thanks a lot.
Well, yeah, that was really cool. Do you by any chance have a link to a repository with some of the code if somebody is interested in studying like an example or best practices or something?
Yeah, sure. So I forgot to include it here in the presentation, but I will share it in the Slack channel in a moment. So I have one.
Um, One question is also like, is there, how did you or when did you start exploring it? And is there like a specific project where you're making use of those new capabilities?
Yeah. So uh, I was basically motivated to learn Rust because I was seeing that some cool utilities were built with that. So kind of, uh, yeah, I was curious, like, okay, why they choose to do it in Rust. So I just started like practicing doing some command line tools, but and when I started looking at examples of how to use it in the web, and just looking at what's possible nowadays uh, in terms of performance, and like the thing that you can run in a web browser. So that's like where my interest is. So because I just, and I saw that some people just migrated some code without a lot of effort. So that was kind of curious, like how it's possible to run such a complex project inside the web browser. And so I guess that from that I started to try to understand how things communicated between themselves, and I'm still on that path because there's a lot of tools, and I think this is evolving like every day, and some utilities are making stuff easier, right? Like every week, like there's someone creating some library that makes some operation or some, I don't know. So there's a lot of stuff happening, but I think that like that the web platform is like the evolution of the web platform will include a lot of stuff created with tools like this, not necessarily with Rust, but I think WebAssembly will be part of that evolution. So it's also uh, like curiosity about like how it will look like in the future, and what opportunities will open for us, like for web developers. And also like I like one misconception that I had was that Rust was kind of really hard, and it was just for some low level stuff. But also I realized that it's not necessarily the case. So I'm mostly doing JavaScript and TypeScript in my work, but learning the, the Rust basics is like wasn't that hard. Like I think in JavaScript we deal with really complex problems, like a different kind of problems and complexity, but like there's no reason why we can't learn something like Rust. So yeah, you can go really deep and do advanced stuff with it, but also I found that you can also use it creatively, in a creative way. So yeah, I think that's like there was no specific need or project, but just curiosity for this running in the web platform. Yeah, so not sure if you have any more questions.
It takes just a little bit of time that we always unmute and mute, so I'm sorry. I just wanted to ask you actually if you would put your camera on so that we can see you. So problem is already solved. While I was turning on the mic, you figure out what we need. But yeah, there's some more questions, so I'll pass the microphone first to Mike.
I'm going to cheat and have a couple of questions. So I might have missed it. Where does the Rust code run? Where does it execute?
The, so did you ask like where?
Yeah, where does the Rust code execute? Is it in the client's browser?
Right. So yes, when the browser when you first have to fetch the binary file that was generated by the Rust tool that the Wasm bindgen tool, and it will create a separate space in the browser that has like its own memory allocation routines, and it's kind of separated from the JavaScript memory space, so it's not like restricted by the garbage collection that JavaScript uses. So yeah, it has a simple memory layout with different rules, and that's like an advantage in some cases because yeah, you are not limited by the, as I said, like the garbage collection. But yeah, sometimes you have to be careful about when to free memory. In this case, because Rust help us with that. So there's some like
So is there like
it's
a?
not something difficult to do.
Oh. Yeah, I was. So what I was slightly confused about was, so say I've got a Mac with an M1. Like, how's the code? What's the relationship between compiling and running the code? Because if it's compiled code, the binary
Yeah.
is going to be for a certain process. So how does that work?
So yeah, it is compiled, but it is compiled to a set of instructions that is specified by the WebAssembly specification. So is kind of a limited set of instructions. So in this case, it's not like compiled to code that runs directly on the processor, but what is provided by the browser here is the engine that can the WebAssembly uh, interpreter that can actually execute that code. So that's why you have to, when you are going to compile your Rust code, you have to specify what's the target. And there's a different target for WebAssembly. It's called Wasm dash unknown, something like that. Uh, so yeah, like that's
And I should look up what Wasm works probably to answer my question fully, but it sounds a bit like the JVM for Java code, where you've got where it's sort of semi-compiled to byte compatible, that the underlying Wasm runner can run the code. Sounds like that,
so.
but maybe.
Yes, like it doesn't have uh, a virtual machine like in it, you like it's not directly it's not exactly a virtual machine, but it just provides a set of native instructions that look like assembly, but are are really fast to execute. So, but yeah, like I haven't go like deeper to just see like where when the binary code is executed, like how's the relationship with the actual processor execution. So I think there's some interesting area to research.
Patience explaining it as well. Thank you.
Hello.
Hello.
So I currently am working on a project that's using you, and you kind of mentioned in your talk that like you don't think using like JSys or WebSys on top of Wasm BindGen is really necessary. Um, do you think you can expand on that a little? Because like, what do you think these libraries actually provide on top of Wasm BindGen, and what would be what benefit do you think there is to using just Wasm BindGen and not a library that sort of makes it easier on top of it?
So I think it's a matter of like context and preference too, because I've seen like with something like WebSys, you can, for example, create, I don't know, some WebGL context and like the logic that writes to it. So what it does is just like you are using the native language, like maybe it's Go or Rust, uh, and you are using the conventions for that. So if you prefer that, and you prefer to have like the the logic that creates the actual web elements from inside your the other language, uh, I think that's okay. I've seen some code that uses like a lot of rows to create, for example, the web worker example that I show. Uh, Another possibility is to actually create the web worker from inside Rust using the wrapper that is provided by the WebSys layer. But in the end, it will be like this the same, because uh, those elements like the web worker, the WebGL, the audio context, all of those are defined in the web platform. So um, one I mean, maybe one criteria if you is to avoid like going back and forth, because that communication between the two space, like the Rust and the WebAssembly uh, module and the JavaScript world, like there's some performance considerations. So sometimes it makes sense to just do everything at once from one side. But yeah, I mean, I think that's really dependent on the project. Some projects are really more Rust focused, and you just feel more comfortable working from inside Rust. So like there's an advantage for people in that place, because you can now use all the web platform elements, and you can even create DOM elements from your Rust code and set their attributes. And these intermediate layers provide kind of uh, a straightforward way to use those. Like sometimes, because they are like web platform elements. Like there are some weird things in the signatures that you will see in the Rust generated wrapper, but there's there's an option to do it. So yeah, you can go like even create your whole application inside Rust. But like there's some also drawbacks to do that, because at that point you will lose like the the flexibility of JavaScript. So I found like myself that for things that are DOM related, or that are like native to the web platform, like having wrapper functions in JavaScript and just allow Rust to call those, makes the code clearer, and also someone with JavaScript knowledge can still like work on the project, and we don't add the requirement of just having to know a more complex language like Rust. But yeah, it's very subjective, I think.
Yeah, so you're basically saying because I'm a Rust dev, it makes sense for me to use the libraries, but if a JavaScript dev wants to work on it, it might make sense to use Wasm Bindgen.
I mean, Wasm Bindgen is is kind of the bridge that will allow you to in both cases you will use that. So for a JavaScript developer, maybe the interest is just to consume some Rust library without knowing too much about the details. But yeah, maybe. But I will say that also if you are a Rust developer, it makes sense to try to do not bring everything from the web platform, because the way that the DOM API is defined and other web platforms APIs are defined, sometimes it will kind of look verbose in your Rust code because it won't be that natural. So there will be some considerations in terms of maintainability too, if you use everything in Rust. But it's an option too.
All right, I think that was all the questions that the audience had. Thank you very much for presenting this amazing talk. Like I wasn't yet able to go that deep, and like I didn't know all of that. So basically, next time I want to try Rust, I'll just rewatch the talk on YouTube and then ask you the rest. But yeah, that's really cool.
Yeah.
Thanks.
Thanks a lot. Hope to see you soon.
So yeah, see, maybe next year make an update.
Yeah, I really want to
Yeah,
to
next
go
year you have to
and
join too. If you have any favorite location, then let us know in advance, so it's still open.
yeah, yeah. Thanks a lot, and hope you keep enjoying the
Yeah.
event. So
All right.
see you.
Yeah. Bye bye.